This is Unit 2. That first worksheet, that was your 2.1. That's your one-step equations. Now we're going to 2.2 notes. 2-step equations. Alright, so the most typical type of two-step equation you're going to see is something like this. 3x plus 5 equals 19. So, when we are solving an equation, always, I'm going to write over here, our goal. Okay? Our goal is to isolate the variable. What in the world does that mean? What? X. X is our variable in this particular equation. Sometimes we use different variables, but in this particular case, equation we're using X. What's it mean to isolate X? By itself, right? If you get put in isolation, you're all by yourself. So, so this really just means get the X by itself. That's our goal when we're solving an equation. Any equation, really. That's going to be true even whenever you get beyond linear equations that are more difficult. But we got to get that X by itself. So this X right here, we want it to be alone. But right now it's not alone. Because this line right here splits our equation into two parts. And over here with this X, I've got a 3 and I've got a 5. And I have to get rid of the 3 and the 5 so that I can get that X by itself, so I can isolate that variable. So, I've got to decide which one I have to get rid of first. What do you guys think? What needs to be done first? Got to deal with that 5 first. You want to start with the numbers that are furthest away. That's sort of a vague term to use, but furthest away from your X. That 3 is right beside of the X. So it's going to be dealt with last. It's the opposite of order of operations. Right? So normally we would multiply before we would add. To undo that, you have to get rid of the addition before you can get rid of the before the multiplication. So it's the opposite of the way you would do the order of operations. If you think, one of my math teachers used to use this example. Any of you have that aunt or uncle or somebody in your family that at Christmas time will give somebody a present? And it's like a box, inside of a box, inside of a box, inside of another box. Then that might be wrapped in zip ties and duct tape, and then it takes you 20 minutes to open the present. So it's kind of like that. Order of operations would be like how the person wrapped it up, right? They put it in the small box first, and then the next, and next, and next. Well, solving equations is like you unwrapping. You got to start on the outside and work your way in close to that prize that you want in the middle of that present, all right? So, so they're opposites of each other. So we've got to deal with this plus 5 first. Ian, what am I going to do to get rid of that plus 5? I'm going to subtract that 5. If I do that on the left-hand side, I must also do it on the right-hand side. At least for the next couple days, I want you to write that down, that you've done that, okay? So show your work on that. Once you've proven yourself as an equation solver, I may look the other way if you're skipping a few steps, but right now, show your work. So, we'll get, okay, well, that's fine, that's fine. Okay, so then, I've got the 3 and the X here. I'm wanting to get that X by itself. I got to get rid of 3. Lexi, what could I do to get rid of that 3? divide. I'm going to divide both sides by 3. The reason I said old is because I thought I was coming up with one that gave me a whole number answer. Does this give me a whole number answer? No. Improper fractions are fine. That will not reduce. That is your answer. You may see some where you don't get a whole number as your answer, so that is perfectly fine. If I want to check, that means I would take the equation 3x plus 5 equals 19, and I would erase that x and replace it with 14 thirds. And I want to see if it really does equal 19. What is 3 times 14 over 3? It's actually much easier to do than it sounds. Because 3, if I make it a fraction, it's 3 over 1. If we reduce before we multiply, what can happen to this 3 and this 3 right here? They reduce down to 1. They cancel out. So this is just going to be, sorry. It's not like, sorry, I forgot to set it out. And so that'll be 14 plus 5 equals 19. Does 14 plus 5 equal 19? Yes. So you would know you got it right. Okay, questions? All right, I'm going to do a few that are tricky for kids a lot of times, and then we'll do our assignment. So, example 2. Let's do -6 minus a equals -13. And I do realize, like, you could kind of guess and check on some of these. Like, you could put different numbers there for A and just eventually find the one that works. Guess and check works. It's just the more complicated the equations get, it's going to take forever. So I don't really want you guessing and checking on these because we're trying to learn the process of solving. So I want this A right here to be by itself. I want to isolate that A. So what should I get rid of first? The 6. Okay. How do I get rid of that 6? Very good. I'll add 6 here. I'll add 6 here. -13 plus 6 is going to be -7. Very good. What do I have left on the left-hand side? -A. What students do wrong on this problem right here is they forget that negative. Because this plus and minus, that only got rid of this stuff here. That negative right there has to be carried down. Okay? Now, what does that mean when I have -A? How else could I write that? -1A. So that's -1 times A. Evan, how do I get rid of a -1A? How do I get rid of that -1? Such as, like -0 on both sides? So A equals -7? You divide by -1. So because that's -1 times A, you're dividing both sides by -1. But the only thing that dividing by -1 does is it changes the sign of the number, right? So since I had a negative and I'm dividing by a negative, it's just going to make it a positive 7. And so A would be 7 for this. And if you want to check, you can do -6 minus, instead of A, I'm just going to put the 7 there, equals -13. Does -6 minus 7 equal -13? It does. So that is correct. Okay, careful not to lose these negatives right here. They're really easy to lose. All right, and then here's the other two types of equations that students have trouble with. And they have trouble with them because many of you suffer from fractophobia, where you're terrified of fractions. Fractophobia, by the way, is probably not a real term for fear of fractions. I don't know if there's an official term for that or not. Probably is. Okay, so when I'm looking at this equation, first of all, students think that it is a fraction. It's really not a fraction. It's really just divided by 8 is what we're dealing with there. Our goal is the same as it always is. We want to get that variable by itself. We want to isolate that variable, so that x needs to be by itself. So I've got to decide whether to get rid of the 3 or the 8 first. Okay? What do you think, Aiden? The 8. Because they're not written, but when we have a fraction written like this, it's like we have parentheses around that numerator. So that x is grouped with the x, with the plus 3. Those are the closest together. Now, like, actually, the 8 and the 3, they're probably about the same distance away if we're measuring it with a tape measure. But because there are implied grouping symbols there, whenever we write a fraction this way, we got to deal with the 8 before we can mess with that 3. So it is divided by 8. So Aiden, how do I reverse that? Okay, I will multiply by 8 here and also multiply by 8 on the other side. This 8 will cancel with the 8 in the denominator. It will just leave me with x plus 3 on that left-hand side. Negative 2 times 8 is negative 16. And so now I'm trying to get the x right there by itself. Camel, what do I need to do now? What? I can, but I don't have to. Because it's really just going to add like an extra step right there. If I put that 1, there might be times where you might want to do that, but I don't have to. What I really need to do is get rid of this plus 3. How can I get rid of it? I can't put it with the x because x plus 3, I can't add those together. They're not like terms. So the opposite of adding 3 would be to subtract 3. So I'll subtract 3 from both sides. It will cancel over here on this side. I'll get x equals, what is negative 16 minus 3? Negative 19. Again, you can always check your answer. Negative 19 plus 3 over 8 is supposed to equal negative 2. So negative 19 plus 3 is negative 16. And does negative 16 over 8 equal negative 2? It does. So you know that your answer is correct. We okay here? All right. Last type I'm going to give you right now before we do some work on our own. This one looks a lot like the last question. It looks like it has a fraction in it, But it is a little bit different because the 7 does not divide everything. It only divides the h. So in this case, when we write a fraction this way, it's like there's implied parentheses around the h over 7. So we need to get rid of the 5 first in this case. So Giancarlo, what would I do to get rid of that 5? Very good. What's that going to give me whenever I do that, Giancarlo? Positive 7. Very good. And then that leaves me with h over 7 equals 7, which looks like a fraction, but it's really not. It's h divided by 7. Anna Grace, what do I do to get rid of that 7 that's in that denominator? Good. I'm going to multiply by 7, which will cancel over here. Multiply by 7 over here. So h will equal 49. And if I want to check, I would do 49 over 7 minus 5 to see if it does equal 2. 49 divided by 7 would be 7. 7 minus 5 does equal 2, so that lets me know that my answer is correct. Okay, questions? Alright, so I've got a worksheet for us, and this will be your homework if you do not get it finished in class. There's not a ton of room on this worksheet. I do want you to show work. So, if you can do that by writing really small, it is okay to just do your work on this worksheet. If you have big handwriting and you are not going to be able to have enough room, please get an extra sheet of paper for this. Because I think it can be done if you are okay with writing small, but there are some people that just do not write small very well. So, we're going to work on this for the rest of the class. If you get it finished, then I want you to let me check it before you put it away, because I want to see how you are doing. And I don't know if I have it. Well, we might have some of it finished. Let me see here.